What do you think this is? Well, looks like a bunch of scribbles to me. What if I told you that these scribbles actually have three very distinct lines or strands which have very unique properties of their own? Would you be able to distinguish between them and make sense of this mess? Well, you wouldn't be. Um, what if I told you that your noise cancelling headphones actually do this on a daily basis? Well, to understand the complexity of the issue, let's think of it as unmixing a box of paint. If I gave you a box of red paint and blue paint, told you to mix it up real well, and until it becomes purple paint, then give you back the purple paint and tell you now separate it back into red and blue, would you be able to do it? Not really. Then how does your noise cancelling headphone really do it? Well, it is through something called a Fourier transform. A Fourier transform is nothing but a mathematical equation that was devised by a person called Fourier back in the 1800s. The Fourier transform answers one of the most fundamental questions of electronics, which is how to separate a signal from noise. And to demonstrate this a bit further, let me do a demo. This is sound A, which is a primary pure sound constituting of no other sound other than A. Whereas this is B, which again is a primary sound which is one octave lower than A but is pure and has no other constituent sounds other than itself. Now if I play both of them together, we get something called as C, which is again a completely new sound wave. So you need to keep in mind that your noise cancelling headphones actually hear C. They never hear A or B, which means when I'm talking, your headphones can actually hear the rustling of my coat, the rustling of the curtain, the sound outside my house, the construction, the rain, and everything. But you only hear my sound and my voice. How does that happen? It happens in 3 steps. 1, it first differentiates the input signal. If it's a primary signal, it keeps it that way. But if it's a mixed signal like C, it understands that it is constituted of 2 things like A and B. And then it would realize, well, I don't really need A, so let me just remove B. So then you would get something called A. And that is my voice that you're hearing right now over the rustling of the curtain and the sound of rain. So this is not really just applied to sonics. This is also applied to electronics. And it has made our lives a lot easier. So next time someone gives you mixed signals, tell them to unmix a box of paint. Thank you.